Our goal in this section is to be able to graph linear equations in standard form by finding x and y intercepts. First, a linear equation is an equation whose graph is a line. See the word line in linear? Linear makes a line when we graph. Standard form is just one of the forms that we're going to use for a linear equation. Standard form for a linear equation looks like this. Ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So standard form is what we're focusing on today. Standard form looks like this. The x and y on one side, the constant term on the other side of the equal sign. We can graph a linear equation in standard form by finding x and y intercepts. That's one way to do it. So let's recall that an x-intercept, or a 0, is where the graph crosses or touches the x-axis. So if you think about the graph, and here's the x-axis, if the graph crosses the x-axis, think about what the ordered pair is for that point. The x will be some number and the y will be 0. So for an x-intercept or a 0, that is where y equals 0. Similarly, the y-intercept is where the graph crosses or touches the y-axis. Remember what that looks like. Here's the y-axis, and if the graph crosses or touches the y-axis, the point where it crosses would be 0, and the value for the y. So the x is always 0. X is 0 for the y-intercept. Let's look at some examples. Graph each of the following linear equations. Notice I just underlined the part of linear that says line. So we know when we graph it, it's going to look like a line. Number 1, 5x plus 2y equals 10. Let's start by finding the x-intercept. Now the x-intercept, remember, is where the y equals 0. So if we take our equation, 5x plus 2y equals 10, and we make the y 0, well, 2 times 0 is 0. So we have 5x plus 0 equals 10, because the y is 0. And then we have the rest of the equation. 5x plus 0 makes 5x equals 10, and we solve this equation. How do we solve? 5 times x, we divide both sides by 5, and we're left with x equals 2. So the x-intercept is where the x is 2 and the y is 0. It would be the point 2, 0. Then we'll find the y-intercept. The y-intercept, remember that's where the x is 0. So we take our equation, 5x plus 2y equals 10, and we make the x 0, which makes this whole term 0, since 5 times 0 is 0. So 0 plus 2y equals 10, and 0 plus 2y, using our identity property of addition, is just 2y. So 2y equals 10. Then we can divide both sides by 2, and we're left with y equals 5. So the y-intercept is where the x is 0 and the y is 5, 0, 5. Then we can go to our graph, take the point 2, 0, find the x-axis, 2, 0, plot that point, and then the y-intercept, 0, 5. 1, 2, 3, 4, 5, and plot that point. We know we're going to be graphing a line, so I connect the 2 points to make a line. I probably want to get my straight edge to make sure I'm doing that properly, maybe my ruler. Notice that my graph has arrows to indicate it's a line, it will keep going, and that it goes past these points. Notice that looking from left to right, the graph is coming down. The graph is decreasing. Let's write that. The graph is decreasing. And what that means is the slope of the graph is negative. If the graph is decreasing, the slope is negative. Now, because we're using the x-intercept where the y is 0, some people call this the cover-up method. You can take your hand and from the equation cover up the part that's 0. So notice if we put our hand over the y, because the y is 0, we cover up the y, we're left with 5x equals 10. So we have 5x equals 10, and then we solve that mini equation. Similarly, for the y-intercept, when the x is 0, we can cover up the x term. Notice I don't cover up the sign in front of the 2y, so I have positive 2y equals 10. Positive 2y equals 10. Let's take a look at another example. Number 2, 4y minus x equals negative 4. Now notice this isn't quite in standard form because the y is coming before the x. So first thing we should do is turn this around. It's negative x, so I will write negative x, and it's positive 4y. So plus 4y equals negative 4. Now it's in the proper standard form. Let's begin by finding the x-intercept. There will be 1 when it's a line. The x-intercept, remember, is where the y is 0. So I'll take my equation, negative x plus 4y equals negative 4. And because the y is 0, I'm taking out that y term. The y is 0. So I will write negative x plus 0, because I'm taking out the y term, it is 0, equals negative 4. Since this is 0, I have left over negative x equals negative 4, and then I can divide by negative 1 on both sides. Remember that invisible 1 in front of multiplied to the x. Dividing by negative 1, x equals 4, so the intercept is 4, 0. Let's now find the y-intercept. That's where the x is 0. So we'll take negative x plus 4y equals negative 4, and the x will be 0. So 0 plus 4y equals negative 4. Using our hand, we're covering up the x term. So left over, adding 0 leaves us with 4y equals negative 4, and then dividing by negative 4, I'm dividing by this 4, positive 4, on both sides. I have y equals negative 1. So the y-intercept is 0, negative 1. Now I'm going to graph the x-intercept. 1, 2, 3, 4, 0, and the y-intercept, 0, negative 1. And then I connect these points, use my straight edge to make sure I'm graphing a straight line, put arrows to indicate it will keep going. And then let's describe what the graph is doing. From left to right, the graph is moving up. The graph is increasing. And because the graph is increasing, the slope is positive. Number 3, y equals 4. Now in this one, there isn't an x and a y, just a y. But we can think of this similar to the other ones. let's start with talking about the x-intercept. Remember, the x-intercept is where the y is 0. So I take my equation, y equals 4, and in place of the y, I put 0. 0 equals 4. Well, that's not true. 0 and 4 are different numbers. 0 does not equal 4. So because 0 does not equal 4, there is no x-intercept, because that's not a solution. No x-intercept. Let's look at the y-intercept now. That's where the x is 0. So I'll take our equation, y equals 4, and in place of the x, I'll put 0. But I don't have an x, so I'm left with y equals 4. My y-intercept is 0, 4. The x is 0, the y is 4. Now we can go to our graph. The x-intercept, there is none. The y-intercept is 0, 4. 1, 2, 3, 4. Now remember, there's no x-intercept, so the graph does not ever cross the x-axis. So I can't make it come down. I can't make it go this way. It can never touch the x-axis, which means it has to go across. It has to be constant. It has to be horizontal. So here is this graph. It is a constant graph, neither increasing nor decreasing. It is constant. It goes right to left, so it is called horizontal. And the slope is 0, not positive or negative, 0. Let's look at one more example. Number 4, x equals 1. Again, we'll start with the x-intercept. That is where the y equals 0. So for our equation, x equals 1, I don't see a y, so I can't put 0 for the y. So I stay with x equals 1. That means my x-intercept is 1, 0. My y-intercept, that is where the x equals 0. So I take my equation, x equals 1, and in place of the x, I put 0. 0 equals 1. Well, that's not true either. That's no solution. So therefore, there is no y-intercept. The graph can never cross the y-axis. Let's go to the graph. On the x-axis, I plot 1, 0, and the line can never cross the y-axis. So this will be a vertical line. It can only go straight up and down because it can never cross the y-axis. This is not a function, so I can't describe it as increasing or decreasing. Let's just remind ourselves that this is not a function. But I can describe it as a vertical line, and because it's not a function, the slope is undefined. Take a couple minutes to write a short summary. Describe the process for graphing a linear equation from standard form. See you in class.